Assalamu alaikum students. Today we will discuss vapor compression refrigeration cycle through pressure enthalpy diagram. It is one of the most widely used refrigeration cycle in chillers, refrigerators, air conditioners and many other cooling systems. This refrigeration cycle operates by compressing and expanding a refrigerant which rejects and absorbs heat to provide cooling. Now let's discuss each component of this cycle step by step as refrigerant moves through it. In order to make it simpler and easier to understand, I would like to explain this concept by taking the example of air conditioners. So starting from evaporator, in the evaporator of air conditioners, heat exchange takes place between the refrigerant and the room air. The refrigerant circulates inside the tubes of evaporator. As a result of heat exchange, refrigerant absorbs the heat of room air and changes its phase from saturated liquid vapor mixture state to saturated vapor state at the outlet. During this phase change, the enthalpy of refrigerant increases as you can see in this diagram, while the pressure remains constant throughout this phase change. Different types of compressors are used for compression of refrigerant. In case of air conditioners, scroll, rotary and reciprocating types of compressors are widely used. In compressor, mechanical energy is required to compress low pressure, low temperature refrigerant which is in saturated vapor state in order to reduce its volume and increase its pressure. The work done on the refrigerant during this compression is converted into internal energy of the refrigerant. As internal energy of the refrigerant increases, its temperature also rises. So, at the outlet of compressor, we have high pressure, high temperature refrigerant in superheated vapor state. In the condenser of air conditioner, heat exchange takes place between the refrigerant and the surrounding outside air. Refrigerant circulates inside the tubes of condenser. As a result of heat exchange, refrigerant releases its heat to the surrounding air and changes its phase from superheated vapor state to saturated liquid state. During this phase change, enthalpy of refrigerant decreases significantly while the pressure remains constant throughout the condenser. In throttling device such as a capillary tube or expansion valve, refrigerant undergoes a sudden drop in its pressure as it passes through the restriction. During this process, enthalpy of refrigerant remains constant. As a result of pressure drop, the temperature of refrigerant also decreases significantly, which produces a low pressure, low temperature, saturated liquid vapor mixture of refrigerant at the outlet. This cold refrigerant enters the evaporator ready to absorb the heat of room air and repeat the whole refrigeration cycle again. Now if I summarize this whole refrigeration cycle, isobaric heat absorption is taking place in the evaporator. After that, isentropic compression is performed in the compressor, while isobaric heat rejection is taking place in the condenser, and in the end, isenthalpic expansion is performed in the throttling device. For coefficient of performance of this refrigeration cycle, we take thermal kilowatt of evaporator in the numerator and work done by the compressor in the denominator. Another easy method to find coefficient of performance for this refrigeration cycle is that we take saturated temperature of evaporator in the numerator and the difference between saturated temperatures of condenser and evaporator in the denominator. I hope your concept about vapor compression refrigeration cycle is quite clear now. Do let me know if you have any question about this concept. I would love to answer your queries. Thanks for watching.